Welcome to Propulsor's Career Point. This is a video for the student of class 11 in the name of practice series for examinations as per modified question pattern. After the completion of the chapter, different examinations like chapter review test, part review test, unit review test, half yearly test, annual examination, etc. In the chapter Chemical Equilibrium. Unit 7 ର ପ୍ରଥମ ଚାପ୍ଟର କେମିକାଲ ଇକ୍ୱିଲିବ୍ରିୟମ୍ ଉପରେ ସେଭରାଲ ଇମ୍ପୋର୍ଟାଣ୍ଟ କ୍ୱେଶ୍ଚନକୁ ନେଇ ଏହି ପ୍ରାକ୍ଟିସ୍ ସିରିଜ୍ର ଭିଡ଼ିଓଟି ଏବେ ନଜର ପକାଇବା। ଏଥିରେ କ୍ୱେଶ୍ଚନ ପ୍ୟାଟର୍ନଟି କେମିତି ରହିବ। ଫୁଲ୍ ମାର୍କ୍ସ 20 ଆଣ୍ଡ ଟାଇମ୍ ଡ୍ୟୁରେସନ୍ 45 ମିନିଟ୍ସ। ଯେତେବେଳେ ଚାପ୍ଟର ରିଭ୍ୟୁ ଟେଷ୍ଟ ହୁଏ ଜଷ୍ଟ ଲାଇକ୍ ଇଣ୍ଟରନାଲ୍ ଏକ୍ଜାମିନେସନ୍, ଏଥିରେ 20 ମାର୍କର ପରୀକ୍ଷା ହୋଇଥାଏ, ଯାହା ପାଇଁ 45 ମିନିଟ୍ ସମୟ ଥାଏ। ଏବେ ଆମେ ନଜର ପକାଇବା ଏହାର ଗ୍ରୁପ୍ ଏ ଉପରେ। ୱେଲକମ୍ ଟୁ ଅଲ୍ ଅଫ୍ ୟୁ ଟୁ ଦ ଗ୍ରୁପ୍ ଏ, where all the questions are compulsory, containing the multiple choice questions only. Students, you must have to remember that each question must not require more than 1.5 minutes to write the answer. प्रत्येक प्रश्न उत्तर 1.5 मिनिट भितर आमको लिखा पड़ो। ये समुदाय 5 मार्क पर आम 7.5 मिनिट मैक्सिमम दे पार। एवं नजर पकेबा एक सेक्शन ले प्रथम क्वेश्चन उपर ली चार्टेलियर्स प्रिंसिपल इज एप्लीकेबल टू this. Option A, only homogeneous chemical reversible process. Option B, only heterogeneous chemical reversible reaction. Option C, only physical equilibria. Option D, all the systems chemical or physical in equilibrium. निम्नलिखित मध्य केउंटी ली चार्टेलियर प्रिंसिपल एप्लीकेबल हो पार। ली चार्टेलियर प्रिंसिपल प्रत्येक सिस्टम रे एप्लीकेबल, whether it is physical equilibrium or chemical equilibrium. So option D is the correct answer. That is, Lee Chater principle is applicable to all the systems, chemical or physical equilibrium. Even नजर पकेबा next question number 2 पर। For the reversible reaction N2 gas plus 3H2 gas gives 2 ammonia gas plus heat. The equilibrium shifts in forward direction. Option A, by increasing the concentration of ammonia. Option B, by decreasing the pressure. Option C, by decreasing the concentration of N2 and H2. Option D, by increasing pressure and decreasing temperature. Which is the correct answer? N2 H2 सहित मिस ammonia दब, ये गोटे फॉरवर्ड डायरेक्शन एक्सोथर्मिक प्रोसेस। सो फॉरवर्ड डायरेक्शन शिफ्ट हम जदि आम लोअर टेम्परेचर टेम्परेचर को डिक्रीज करदे ताले इट फेवर्स द एक्सोथर्मिक प्रोसेस। सो टेम्परेचर डिक्रीज करिया को पड़िबो। एवं एज नंबर ऑफ प्रोडक्ट मॉलिक्यूल इज 2 एंड नंबर ऑफ रिएक्टर मॉलिक्यूल इज 4, NP is less than NR, so increase in pressure also favors the forward reaction. So the correct answer is option D. The reversible reaction N2 gas plus 3H2 gas gives 2 ammonia gas plus heat. The equilibrium shifts in forward direction by increasing the pressure and decreasing temperature. Let us come for question number 3. For the reversible reaction 2HI gives you H2 plus I2 plus heat. The equilibrium shifts in forward direction. In which condition? Option A, by increasing the concentration of HI. Option B, by decreasing the temperature. Option C, by decreasing the concentration of H2 and I2. Option D, all of these. The students try to give the correct answer. Out of the following, which is the correct option for shifting the equation in forward direction? Here HI decomposes to give H2 and I2. Number of product molecule is 2, number of reactant molecule is 2. So here pressure is no effect. As it is an exothermic process in forward direction, so the reaction is favored by decreasing the temperature, by increasing the concentration of the reactant, that is HI, also favors the forward direction, or by decreasing the concentration of the product, that is H2 and I2, also favors the forward direction. So the correct answer is all of these. The equilibrium shifts in forward direction either by increasing the concentration of HI, or by decreasing the temperature, or by decreasing the concentration of H2 and I2. Let us come for next question number 4. Out of the following, which is the relationship between Kp and Kc for the Haber synthesis of ammonia. Haber synthesis of ammonia रे Kp और Kc भितर उपयुक्त रिलेशन टी केउंटी? ऑप्शन ए Kp is greater than Kc, ऑप्शन बी Kp is less than Kc, ऑप्शन सी Kp is equal to Kc, ऑप्शन डी any one of these. Haber synthesis of ammonia is represented as N2 plus 3H2 gives 2 ammonia. Here Np is 2 and Nr is 4. So delta Ng is 2 minus 4, that is minus 2. A delta Ng is less than 0. So Kp is less than Kc. So Kp is greater than Kc. Because Kp is equal to Kc into Rt to the power delta n. Delta n is negative here. So delta n Rt to the power delta n negative means divided होगा. ଯେତେବେଳେ Kc को Rt to the power delta n सहित divide करे ସେତେ Kp ହେବ. अर्थात Kp is greater than Kc in case of Haber synthesis of ammonia. Next question, out of the following, which is the relationship between Kp and Kc for the dissociation of Hi? Option A, Kp is greater than Kc, Kp is less than Kc, Kp is equal to Kc, any one of these. Which is the correct answer? Here delta Ng equal to 0. So Kp is equal to Kc into Rt to the power delta n. The delta n is 0, Kp is equal to Kc. That is option C is the correct answer. Kp is equal to Kc. Now we'll come to all of you to the group B, that is the short question section of this year. Here 2 questions need to be answered out of 4 and the total mark is 4 mark, whose answer is to be given within 8 minutes. ये 4 मार्क उत्तर को हमको 8 मिनट भीतर लिखा पड़ो. एवं प्रथम क्वेश्चन पे नजर पकेबा. Derive the relationship between Kp and Kx. We know that Kp is equal to Kc into Rt to the power delta n. Again we know that Kp is equal to Kx into P to the power delta n. So as the left hand sides are equal, we can say Kc into Rt to the power delta n is equal to Kx into P to the power delta n, implies Kc is equal to Kx into P by Rt hot to the power delta n. This is the required relationship between Kc and Kx. Let us come for question number 2. State and explain law of mass action. Come for the statement. What do you mean by law of mass action? Definition. At constant temperature, the rate of a chemical reaction is directly proportional to the product of molar concentration of the reactants is raised to the power equal to the number of molecules of reactants involved in the chemical equation representing the chemical change. ये गला definition कथा. एबे रखिबा explanation कथा. Let us consider a general reaction. A plus BB plus CC gives us product. According to law of mass action, the rate of reaction R is directly proportional to the concentration of A to the power A into concentration of B to the power B into concentration of C to the power C. Implies or R is equal to that constant K into concentration of A to the power A into concentration of B to the power B into concentration of C to the power C. Where R is the rate of the reaction and K is the rate constant. This is the statement and explanation of law of mass action. Let us come for question number 3. Describe the effect of change in temperature in the state of chemical equilibrium. Effect of change in temperature. At equilibrium, if the forward reaction is exothermic, then the backward reaction will be endothermic and vice versa. अर्थात फरवर्ड रिएक्शन एक्सोथर्मिक हम ताले बैकवर्ड रिएक्शन एंडोथर्मिक हम. यदि फरवर्ड रिएक्शन एंडोथर्मिक हम ताले बैकवर्ड रिएक्शन टी एक्सोथर्मिक हम. If the temperature of the system at equilibrium is increased, then the equilibrium will shift towards the direction in which heat is absorbed, that is in the direction of endothermic reaction. On the other hand, if the temperature of the system at equilibrium is decreased, then the equilibrium will shift towards the direction in which it is evolved, that is in the direction of exothermic reaction. Temperature बढ़ेले endothermic reaction rate shift हम. यदि temperature कमेबा ताले equilibrium टी exothermic direction ले shift हम. This is the effect of temperature in the state of equilibrium. एबे question number 4, last question of this group. What are the favorable conditions for the Haber synthesis of ammonia? Haber synthesis of ammonia are favorable conditions of what? The favorable conditions of Haber synthesis of ammonia are increasing concentration of N2 or H2 or both, nitrogen हाइड्रोजन दी में concentration बढ़ेगा, decrease in concentration of ammonia or decrease in temperature because the reaction is exothermic in forward direction, and increase in pressure because Np is less than Nr. These four are the favorable conditions for the Haber synthesis of ammonia. Welcome to all of you to the group C, where two questions are to be answered out of four. Each question require not more than 6 minutes to write the answer. Means here total 6 marks ପାଇଁ ଆମକୁ maximumly 12 minutes ଦେବାକୁ ପଡ଼ିବ, ତେଲେ ଆମେ ପ୍ରତ୍ୟେକ ପ୍ରଶ୍ନର ଉତ୍ତର ଲେଖିପାରିବୁ। ଏବେ ପ୍ରଥମ କ୍ୱେଶ୍ଚନକୁ ଯିବା। What is chemical equilibrium? Write down its general characteristics. ଆମେ chemical equilibrium କହିଲେ କ'ଣ ବୁଝିବା? Chemical equilibrium, the equilibrium established in chemical process is called chemical equilibrium. Let us consider the following general reversible reaction in a closed system. A gas plus B gas is in equilibrium with C gas plus D gas. As the time proceeds on, the rate of forward reaction gradually decreases and the rate of backward reaction gradually increases, and a time will come the rate of forward reaction is equal to rate of backward reaction where the equilibrium state is already achieved. ग्राफ को प्लॉट करिया में देखे दे पारिबो। एबे डिस्क्रिप्शन को नजर पकेबा। At the beginning the rate of forward reaction Rf is maximum due to maximum concentration of A and B. At that time the rate of backward reaction Rb is 0 due to 0 concentration of C and D. As the reaction proceeds, reaction the chalibo, Rf decreases due to decrease in concentration of A and B, whereas Rb, rate of backward reaction, increases due to increase in concentration of C and D. Ultimately, a stage will come when the rate of forward reaction Rf is equal to the rate of backward reaction Rb. This state of chemical reaction is called chemical equilibrium. Thus, at equilibrium, rate of forward reaction is equal to rate of backward reaction, that is Rf is equal to Rb. ଏବେ ଯିବା general characteristics ଉପରେ। At equilibrium, the major properties of the system become constant. Equilibrium can be established only in a closed system. On spelling टा ଟିକେ correction କରିନେବ। The chemical equilibrium is dynamic in nature, that is Rf is equal to Rb, which never comes for completion. A catalyst does not alter the state of chemical equilibrium. At equilibrium, the free energy chain delta G is equal to 0. At equilibrium, the entropy of the system is maximum and the change in entropy delta S is also equal to 0. These are the different general characteristics of chemical equilibrium. ଏବେ क्वेश्चन नंबर 2 पर नजर पकेबा। Describe the application of Le-Chatelier's principle for the dissociation of HI. How can we represent the dissociation of HI? The dissociation of HI is represented as follows. 2HI decomposes to give H2 plus I2. Delta H is equal to minus 54 kilojoule. Effect of change in concentration. Here Kc is equal to concentration of H2 into concentration of I2 by concentration of HI the square. If the concentration of H2 or I2 or both is increased, then the HI will be formed. More HI will be formed. For what? To keep the value of Kc constant. यदि H2 I2 बढ़िबो ताले Kc constant हवा पाई HI मध्य बढ़िबा दरकार। लव बढ़ुची न्यूमरेटर बढ़िले डिनोमिनेटर न बढ़िले Kc केबे constant हे पारिबो ना। It disfavors the dissociation of HI. Similarly, if the concentration of HI is increased, then more H2 and I2 will be formed to keep the value of Kc constant. It favors the dissociation of HI. Maybe second effect को जीवा। Effect of change in concentration पर effect of change in temperature. Here the forward reaction is exothermic, while the backward reaction is endothermic. So if the temperature of the system at equilibrium is increased, then the equilibrium will shift towards the direction in which heat is absorbed. That is the direction of endothermic reaction. That is more HI is formed. This disfavors the dissociation of HI. On the other hand, If the temperature of the system at equilibrium is decreased, then the equilibrium will shift towards the direction in which it is evolved. That is in the direction of exothermic reaction. There is more Hi under dissociation to form H2 and I2. Thus, it favors the dissociation of Hi. ଏବେ ନଜର ପକେଇବା ଅପସନ୍ ସି ଉପରେ ଇଫେକ୍ଟ ଅଫ୍ ଚେଞ୍ଜ ଇନ୍ ପ୍ରେସର ହିଆର NR is equal to 2 and NP is equal to 2. Number of reactant molecule is equal to 2 and number of product molecule is also equal to 2. So increase or decrease in pressure has no effect in the state of equilibrium. Now let us look for the question number 3. Describe the effect of change in pressure in the state of chemical equilibrium. Chemical equilibrium change in pressure कौन effect होता है? Effect of change in pressure. If the system at equilibrium consists of gaseous reactants and products, then there is difference in number of reactants and product molecules. Then the change in pressure plays an effect in the state of equilibrium. जदि reactant product गुड़िक gaseous state थिबे एवं reactant और product molecule संख्या रे difference थिबो ताले pressure effect रहिबो. Case 1, for NR is greater than NP. जदि NR NP 2 बेसी है, when NR is greater than NP, then the increase in pressure shift the equilibrium in forward direction and vice versa. मुझे temperature कमे दबा ताले backward direction ले जाओ. Sorry, pressure कमे दले backward direction ले जाओ. Example टी निया इसे एग्जाम रे चाहिए जदि 3 मार्क का क्वेश्चन ले तुम्हें चाहिए भी एग्जांपल को अवॉइड करि पारिबो. Example, consider the Haber synthesis of ammonia. N2 plus 3H2 gives us ammonia. Here NR is equal to 2 and NP is equal to 4 and NP is equal to 2. So increase in pressure shifts the equilibrium in forward direction and more ammonia is formed. Case 2, for NR is less than NP. When NR is less than NP, then the increase in pressure shifts the equilibrium in backward direction and vice versa. Means the pressure बढ़ेगा ताले forward direction rate बढ़ेगा. Example 10, let us consider the decomposition of N2O4. Whenever N2O4 decomposes, it will give us 2NO2. Here NR is equal to 1 and NP is equal to 2. So increase in pressure shifts the equilibrium in backward direction. That is more N2O4 is formed. Case 3, for NR is equal to NP. So the number of reactant is equal to number of product molecule hobo, then increase or decrease in pressure has no effect in the state of equilibrium. कौन सी effect रही बनाए? We can, for example, we can take the example of dissociation of HI. Here NR is equal to 2 and NP is also equal to 2. So increase or decrease in pressure has no effect in the state of equilibrium, that is in the state of dissociation of HI. Last question of this group. Derive the law of chemical equilibrium by using law of mass action. Law of mass action को यूज करिए हमें chemical equilibrium को derive करिए. Let us consider the following general reversible reaction. AA plus BB is in equilibrium with CC plus DD. Let RF is the rate of forward reaction, RB is the rate of backward reaction, and ABCD are the concentration of ABCD respectively. According to law of mass action, RF is directly proportional to concentration by A to the power A and concentration by A to the power B. Implies RF is equal to Kf into concentration by A to the power A into concentration by A to the power B, where Kf is the rate constant for forward reaction. Similarly, RB is directly proportional to concentration of C into concentration of D. Implies RB is equal to Kb into concentration of C into concentration of D to the power D, where Kb is the rate constant for backward reaction. Now at equilibrium, RF is equal to RB. Equation 1 and 2 आमे लिखी पारिबा. RF जगह Kf into concentration of A to the power A into concentration of B to the power B is equal to RB जगह लिखी पारिबा Kb into concentration of C to the power C into concentration of D to the power D. Implies Kf by Kb is equal to concentration of C to the power C into concentration of D to the power D divided by concentration by A to the power A into concentration of B to the power B. Kf is a constant and Kb is a constant, so their ratio is also a constant. Let it be Kc. implies Kc is equal to concentration of C to the power C into concentration of D to the power D whole divided by concentration of A to the power A into concentration of B to the power B. Where Kc is another constant known as equilibrium constant in terms of molar concentration. The above equation is known as law of chemical equilibrium, which is stated as follows. At constant temperature, the ratio between the product of molar concentration of the product molecule to the product of molar concentration of the reactant molecules is raised to the power equal to the number of molecules of each kind present in the balanced chemical equation, representing the chemical equilibrium, is always a constant known as equilibrium constant. This is known as law of chemical equilibrium. Now, welcome to all of you to the Group D. There is a long question section where one question is to be answered out of two. Each question requires not more than 12.5 minutes to write the answer. ଏଇଭଳି 5 ବାର ପାଇଁ ଏଠି 12.5 ମିନିଟ୍ ସମୟ ଦିଆଯାଇପାରିବ। Question number 1 ଉପରେ ନଜର ପକାଇବା। State and explain law of mass action. Derive the equation for equilibrium constants Kp and Kc. Derive the relationship between them. आमे law of mass action को statement लिखिबा, explanation करिबा, तापर law of chemical equilibrium derive करिबा, Kp Kc ପାଇଁ equation लिखिबा एवं Kp Kc भितर रिलेशन काढिबा। आमे law of mass action ठीक कथा ऑलरेडी डेफिनेशन लिखि सारिथिलु। At constant temperature, the rate of chemical reaction is directly proportional to the product of molar concentration of the reactants is raised to the power equal to the number of molecules of the reactant involved in the chemical equation, representing the chemical change. Let us come for explanation. Let us consider a general reaction. A plus BB plus CC gives products. According to law of mass action, the rate of reaction R is directly proportional to the product of molar concentration of A to the power A, concentration of B to the power B, concentration of C to the power C. Implies R rate of reaction R is equal to rate constant K into concentration of A to the power A into concentration of B to the power B into concentration of C to the power C, where R is the rate of reaction and K is the rate constant. Derivation of equations for Kp and Kc. Let us consider the following general reversible reaction. A plus Bb gives us Cc plus Dd. Let Rf is the rate of forward reaction, Rb is the rate of backward reaction, and ABCD are the concentration of the reactants and products respectively. According to law of mass action, rate of forward reaction is directly proportional to concentration of A to the power A into concentration of B to the power B. Implies Rf is equal to Kf into concentration of A to the power A into concentration of B to the power B, where Kf is the rate constant for forward reaction. Similarly, for backward reaction, we can get Rb is equal to Kb into concentration of C to the power C into concentration of D to the power D, where Kb is the rate constant for backward reaction. We know that at equilibrium, Rf is equal to Rb. I mean equilibrium ne janichu Rf is equal to Rb. So from equation 1 and 2 we can write down Kf into constant of A to the power A into constant of B to the power B is equal to Kb into constant of C to the power C into concentration of D to the power D. Implies K by Kb is equal to concentration of C to the power C into concentration of D to the power D whole divided by concentration of A to the power A into concentration of B to the power B. Kf and Kb are constant, so their ratio is also a constant. Let it be Kc. Implies Kc is equal to concentration of C to the power C into concentration of D to the power D whole divided by concentration of A to the power A into concentration of B to the power B, where Kc is another constant known as equilibrium constant in terms of molar concentration. Now gote baki rahila Kp kotha in terms of partial pressure. If all the reactants and products remain in gaseous state, then the above equation for Kc can be written in terms of partial pressure as follows. That is Kp is equal to partial pressure of C to the power C into partial pressure of D to the power D whole divided by partial pressure of A to the power A into partial pressure of B to the power B. Now relation between Kp and Kc. We know that Pv is equal to nRT, implies P is equal to N by VRT. N by V is nothing but concentration C. So P is equal to CRT. So we can write down PA is equal to concentration of ART. PB is equal to concentration of BRT. PC is equal to concentration of CRT. And PD is equal to concentration of TRT. Again we know that Kp is equal to partial pressure of C to the power C into partial pressure of D to the power D whole divided by partial pressure of A to the power A into partial pressure of P to the power P. Now putting the value of PC, partial pressure of PA, PB, PC and PD, we can write the equation, and by solving we can write down Kp is equal to Kc into RT to the power C plus D minus A plus B, which is briefly known as Kp is equal to Kc into RT to the power delta N, where delta N is the number of product molecules minus number of reactant molecules. Let us come for the question number 2, the last question of this video. State and explain Lee-Chatelier's principle. Describe the application for the Haber synthesis of ammonia. आम ली-चार्ट प्रिंसिपल स्टेटमेंट लिखा तार एक्सप्लेनेशन करवा. लेट अस कम फॉर द स्टेटमेंट. इफ ए सिस्टम अंडर इक्विलिब्रियम इज सब्जेक्टेड टू चेंज इन कंसंट्रेशन, टेम्परेचर और प्रेशर, then the equilibrium is shifted towards the direction which tends to reduce or cancel the effect of change. जदि गोटे सिस्टम इक्विलिब्रियम थी तार टेम्परेचर प्रेशर बा कंसंट्रेशन आम चेंज करूँ ताले इक्विलिब्रियमटा गोटे डायरेक्शन शिफ्ट हम से चेंज रो इफेक्ट को कमे देवाई बा कैंसल करने. लेट अस कम फॉर द एक्सप्लेनेशन इफेक्ट ऑफ चेंज इन कंसंट्रेशन. If the concentration of any one of the reactants or all is increased, or the concentration of any one of the products or all is decreased, then the equilibrium is shifted towards forward direction to minimize or cancel the effect of change and vice versa. जदि रिएक्टांट concentration बढ़ेबू बा प्रोडक्ट concentration कमीबू तार इक्विलिब्रियम फॉरवर्ड डायरेक्शन ले जीवो एंड वाइस वर्सा. मीन्स जदि आम रिएक्टांट concentration कमे देबू बा प्रोडक्ट concentration बढ़े देबू ताले इक्विलिब्रियम टी बैकवर्ड डायरेक्शन ले शिफ्ट हो. एबे सेकंड इफेक्ट पर चेंज करिबा. इफेक्ट ऑफ चेंज इन टेम्परेचर एट इक्विलिब्रियम. इफ द फॉरवर्ड रिएक्शन इज एक्सोथर्मिक, then the backward reaction will be endothermic and vice versa. If the temperature of the system at equilibrium is increased, then the equilibrium will shift towards the direction in which heat is absorbed, that is in the direction of endothermic reaction. टेम्परेचर बढ़ेले एंडोथर्मिक रिएक्शन ले इक्विलिब्रियम शिफ्ट हो. ऑन द अदर हैंड, इफ द टेम्परेचर ऑफ द सिस्टम एट इक्विलिब्रियम इज डिक्रीज्ड, देन द इक्वेशन विल शिफ्ट टुवर्ड्स द डायरेक्शन इन व्हिच इट इज इवॉल्व, दैट इज इन द डायरेक्शन ऑफ एक्सोथर्मिक रिएक्शन. तो टेम्परेचर कमेबा ताले इक्विलिब्रियम टी एक्सोथर्मिक डायरेक्शन ले शिफ्ट हो. एपे इफेक्ट ऑफ प्रेशर ऊपर पकेब. इफ ए सिस्टम एट इक्विलिब्रियम कंसिस्ट ऑफ गैसेस रिएक्टेंट्स एंड प्रोडक्ट्स, and there is change in or difference in the number of reactants and product molecule, then the change in pressure plays an effect in the state of equilibrium. Case 1, for Nr is greater than Np. For Nr is greater than Np, then the increase in pressure shift the equilibrium in forward direction. Case 2, for Nr is less than Np. When Nr is less than Np, then the increase in pressure shift the equilibrium in backward direction and vice versa. Case 3, if Nr is equal to Np, then the increase or decrease in pressure has no effect in the state of equilibrium. Ebe application of Lee-Chatelier principle for Haber synthesis of ammonia. Haber synthesis of ammonia is represented as follows. N2 plus 3H2 gives us 2 ammonia. Delta H is equal to minus 22.8 kilocalorie or minus 92.38 kilojoule. Effect of change in concentration. Here Kc is equal to concentration of square of concentration of ammonia divided by concentration of N2 into concentration of H2 to the power 3. If the concentration of either N2 or H2 or both is increased, then more ammonia will be formed to keep the value of Kc constant. Similarly, if the concentration of ammonia is increased, then more N2 and H2 will be formed to keep the value of Kc constant. Means अदर वर्ड आम कहीपर इंक्रीज इन कनसंट्रेशन ऑफ N2 और H2 और डिक्रीज इन कनसंट्रेशन ऑफ अमोनिया सिर्फ द इक्विलिब्रियम इन फॉरवर्ड डायरेक्शन एंड वाइस वर्सा लिखा जाई परिबो। एबे सेकंड इफेक्ट पकेबा इफेक्ट ऑफ चेंज इन टेम्परेचर। हियर द फॉरवर्ड डायरेक्शन इज एक्सोथर्मिक while the backward direction is endothermic. So if the temperature of the system at equilibrium is increased, the equilibrium will shift towards the direction in which heat is absorbed. That is in the direction of endothermic reaction. That is more ammonia undergo dissociation to form N2 and H2. Thus, it disfavors the synthesis of ammonia. On the other hand, if the temperature of the system at equilibrium is decreased, then the equilibrium will shift towards the direction in which heat is evolved. That is in the direction of exothermic reaction. The more ammonia is formed from N2 and H2. Thus, it favors the synthesis of ammonia. Even another pakeba effect of change in pressure पर here NR is equal to 4 and NP is equal to 2. So increase in pressure if the equilibrium in forward direction, that is more ammonia is formed. Whereas decrease in pressure does not favors the synthesis of ammonia. Thanks for watching Bhopal Sir's Career Point. Please like and share this video. Don't forget to subscribe my channel if you are watching it for the first time.